All right, lesson 3 of chapter 6, education, we're going to estimate the Mincer Earnings Function. Jacob Mincer proposed this model in 1974 to provide a framework for understanding how individuals' earnings are influenced by their education and work experience. In it, we have log earnings. So this log W here is the log of annual earnings from jobs where you have to pay Social Security and whatnot, right? Payroll taxes. So we take the log of that annual value to get log wage. And then we have education. In this case, we're going to use schooling. Schooling is years of education. So this person graduated from high school. This person might have a 2-year associate's degree. This person would probably likely have a bachelor's degree or equivalent, right? 4 years of college. This person has 1 year of college, right? So that's what this is. And then we got the age. We got the travel time to work. One is female is equal to 1 if the person is a female, 0 otherwise. And then we got not metro. It equals 1 if the person does not live in a metropolitan area. Move state equals 1 if moved between states. Immigrant equals 1 if lived abroad a year ago. Hispanic equals 1 if the person is Hispanic. Asian equals 1 if the person is Asian. Black equals 1 if the person is Black. Native equals 1 if the person is Native American. Married equals 1 if the person is married. And then econ equals 1 if the person was an econ major. Okay. So some interesting variables here. We're going to use these variables over here as our X, our matrix of X variables, right? And then education is going to be the schooling variable, right? That's going to be education. Okay, so this is our primary variable. And so what I like to do is I like to color the Y variable. I'll color the Y variable yellow. And then I like to color the X variable, all the X's. We're going to color the X's pink, or yeah, pink. Okay. So this is our Y variable. This is our left-hand side variable. And these ones in pink are the right-hand side variables. Okay. These are independent variables, the ones in pink. These in dark pink to the right of schooling, that's in the X matrix. And this is our primary variable of interest. But everything in pink is on the right-hand side. And the one thing on the left is the left-hand side variable, right? This depends on those factors, right? Okay, so we're going to click on data analysis. We're going to find regression here. We're going to load our input for the left-hand side variable, the dependent variable, which we call the Y variable. I'm going to click on cell B1, right? And then I'm going to hold down the Control Shift button to grab all of the variables, all the values and the label, right? There's a lot of observations here, and the label. So we got the label and the values below it, right? Then I'm gonna click on labels. Then we get the independent variables, right? The ones in pink. I'm gonna one-click schooling, and I'm gonna hold down the Control Shift button, down arrow, and then right arrow to grab everything in pink, right? And all I have to do now is just hit OK. All right, so now I've got to clean up the output a little bit. So I click on column A. I double click this line here to auto fit it. Now I'm going to hold down the control button to grab all these decimal values. So I can set their decimal places to, I don't know, 4. So we'll set these decimal places to 4. There we go. All right, so my adjusted R square is 0.2409. And it says 4 decimal places right there. Okay, so that's my adjusted R square. And then I need my coefficients, right? Now my first coefficient is the intercept. I have put the intercept at the bottom down here. I call it the constant in my math, but it's the intercept in Excel. I'm going to grab the p-value. Well, the p-value is 0.000. And this question here is asking, is this coefficient significant at the 5% level? So I'm going to convert these to percentages, these p-values. So all these are less than 5%, right? Now you might have different ones. The coefficients that are insignificant at the 5% level is the coefficient for moving to a new state, Hispanic, Asian, Native, and economics major, right? Those are all insignificant coefficients. The other ones are significant, right? So I'll do that first. I'll get those loaded first. So everything from schooling down to not metro, right? So schooling, and then move to state is, this coefficient is not significant. Hispanic is not significant. Asian is not significant. And Native is not significant. And then econ is not significant. Everything else is significant. So I'm going to copy that. I'm going to hit enter and just make sure I got it right. Coefficient of the intercept is 7.8099. Schooling's coefficient is 0.1504. Age's coefficient, which is significant at the 5% level, is 0.0127. Transit time is significant. Gender is significant. Not metro is significant. Move to a new state is insignificant. Immigrant coefficient is significant. Hispanic is not significant. Asian is not significant at the 5% level. Being black is significant. Native is insignificant. Being married is significant. And then econ is insignificant. Now, the first question down here, it asks you to interpret the adjusted R square, right? So we want to know what percent of the variation in log earnings can be explained by the above linear model. So we have this linear model here, right? With a constant and all these coefficients multiplied by the various variables, right? So we have this linear model, and we want to know the percent of variation in log earnings that is explained by the model. Well, that is the adjusted R square, right? So I'm going to copy the decimal part of it. I'm going to paste it right here. And I'm going to move the decimal place to, right? And it's going to be 24.09%. So 24.09% of the variation in this is explained by this model here, right? Now we want to interpret these values. So let me go back to the regression results. And it says down here, if the variable has an insignificant effect on log earnings, enter 0 in the respective answer box. Let me go ahead and get those first. Okay, so we got all the insignificant variables set, right? Now, here we're going to put percent different, 0% different, right? 0% different. 0% different, 0% different, and 0% different. So those 1, 2, 3, 4, 5 variables are insignificant. And we're just saying they're going to have 0%. They're gonna not affect log earnings, right? They're not gonna affect your earnings. Okay, now let's go through the significant coefficients. The first one is schooling, right? And the way we interpret these coefficients, if you want to read more about it, you can click on this link. But this coefficient has to be modified, transformed, because we have log earnings on the left and education on the right. So this is a log level model, right? Everything's in levels on the right, but the thing on the left is in logs. So we have to interpret a log level model. Again, if you click on this link, you can read more about it. What we have to do is we have to put the estimated coefficient in the exponent of E, subtract that from 1, and then multiply that by 100, right, to convert it to a percent. And that will give us the percent change in earnings that are associated with a 1 unit increase in X. So what I'm going to do over here is I'm going to delete these columns, and I'm going to add a column here. I'm going to type equal EXP, right? EXP is base E raised to some number. We're going to raise it to this 0.1504 number, right? So that right there is this first part. We're raising the natural number E to this power. Then we're going to subtract that. That equals a number greater than 1, right? So what we want to do is we want to subtract 1 from that. And we get 0.623, blah, blah, blah. And we want to convert that to a percentage. We're going to multiply that by 100. And then I'm going to shrink the number of decimal places up. So this is the percent change in the wage, right? The percent change in wage due to a 1 unit increase in that variable, right? Now, since these are percent changes, so we're going to reduce this to 2 decimal places here. And then I'm going to calculate the rest of them, right? So schooling, the ones that are insignificant are be 0, right? We've already entered them in. Okay. All right. So now let's use that and paste it to here, right? So I'm going to paste that right here so I can fit this in. Okay, so an additional year of schooling is associated with a 16.23% increase in annual earnings. That's what this means right here, right? So each additional year of experience that you get in your life increases your salary by 1.28%. The negative ones are decreases. The positive ones are increases, right? Okay, earnings of female workers are 35.84% less than male workers, right? So when I say percent less, I got to delete the negative sign there. So earnings of female workers are 35.84% less than male workers. Okay. Which is, of note, right? We hear about that a lot, and this data is kind of confirming that. Earnings of married workers is 26.36% higher than single workers. Percent more, right, than single workers, which I think makes sense because if you are married and you have kids, you probably want a higher income, right? A single person is probably not thinking about putting kids in college and whatnot, right? And we already said that native workers variable is insignificant. Black workers, though, let's go to black workers. That coefficient is 15.77 in my model, right? So black workers are going to earn 15.77% less than white workers. And we say white workers because we've included dummies for Hispanic, Asian, Black, and Native. So everything's compared to the white worker, right? If we left out Hispanic, right? If we left out Hispanic and we included the white dummy variable instead, then everything, the coefficients of these variables would be relative to the Hispanic workers, right? But we left out the white dummy variable. So white is our relative group, right? Everything's relative to the white worker because we left out the white dummy variable, right? Okay, moving on. So the Asian dummy variable was insignificant. The Hispanic dummy variable was insignificant. The immigrant workers in my model are going to make 50.49% less, so I'm going to delete the negative sign, than native born workers. And that's probably reasonable too, because the people that come to the United States from other countries who are crossing the southern border and the northern border, they're probably coming here because things in their home country are really, really bad economically, politically. And so when they come here, their skill sets are going to be probably much less because maybe in their home country they didn't get an education. Two, they don't have the paperwork to legally work in the United States. So they're likely going to earn a lot less. They're going to take jobs maybe under the table, right? Cash jobs, because they don't have the paperwork, right? So that completely makes sense there. And then we also said that moving across states, right, in the last year, that was insignificant. Earnings of workers who live outside of metro areas, let's go there. Workers that were, so that is not metro. So workers who live outside of metro areas are going to make 16.15% less than workers who live in metro areas, right? Which is interesting. And that makes sense because to live in a metro area, you need a job that pays more because the cost of living is much more in a metro area than it is in a rural area, right? A 1 minute increase in a worker's commute. So we're looking at the commuting time here. A 1 minute increase in a worker's commute is associated with what? It's associated with a 0.69% increase in annual earnings. So each additional minute of commuting, the worker needs to be compensated for it, right? So workers who have to commute long distances, maybe what's going on here is workers who commute long distances, maybe they're people who make a big salary, and because they make a big salary, they can afford a longer commute. And so they use that larger salary to do what? To buy a home in a more private setting, right? In New York, they might live along the beach in Long Island, right? And that would be a long commute. So it could mean that people with income can afford a long commute and live in a quiet, peaceful neighborhood, right? As opposed to if you make a low salary, you got to live in a crime-infested neighborhood, right? Now, on this one, we're going to do an hour increase in a worker's commute, right? So this is the percent change in earnings for a 1-minute commute. If I multiply this value by 60 minutes, I get 41.4% more, right? 41.4% increase. So if you're for each hour increase in a worker's commute, the person's salary is going up by 41.4%, right? Annual salary is going up by 41.4%. Again, that could be a medical doctor who's making $400,000 a year living in New York, and they actually live out in Eastern New Jersey or Western New Jersey or Eastern Pennsylvania, and they have this long commute into Brooklyn Hospital, right? And then the last one was insignificant, right? So those are our results. They're quite fascinating. I think for the most part, they indicate what is kind of well known, right?